Greetings and welcome. We're taking a look at page 382. We were graphing quadratic inequalities. All right, so parabolas that are either dotted or solid, and they're shaded either above or below. So you actually had a couple options on how to do this. You could have step one. You could have found your vertex. All right, you could have found your roots and your Y-intercept. All right, so that's one technique you could do, right? The vertex, you guys, of course, know. You could find by finding h is equal to negative b over 2a. You could find k by doing f of h, right? The roots, you would set the function equal to 0 and solve, and then the y-intercept is 0c. So that's one option you could have to get the location of the parabola, and then the dottedness or solidness and the shading you'd have to figure out after the fact. Question?
What is for the vertex, what's the second thing?
K is equal to f of h. I know it was written sloppy. Or you could do vertex form, in which we have y equals a parentheses x minus h squared plus k. So either of those techniques would work for giving you the location of the parabola. So let's I'm going to do one problem each. Or I'm kind of just doing whichever problem technically makes sense at the time. So for this might not look it, but this is actually in vertex form. If you don't believe me, what if I wrote it this way? How about that? Same thing, right? X minus 0 is the same as x. So looking at that, look at this. Look up here. Look up here. A is equal to 1. The vertex is, that's not it. There we go. 0 comma negative 16. Right? And it's a regularly shaped parabola. Opens up. Regular. Right? So the slopes are up 1 over 1, up 3 over 1, up 5 over 1. So let me, in fact, grab some graph paper here. Let's see, it's at negative 16. Oh man, this is crazy. So I gotta get all the way down to negative 16. Alright, and I'm just trying to fit it in my window a little bit. And it opens up. So I think from there to there should be good. Paste it. And it is important that you label your scales. You don't have to label like every other point like this, or even every point, or whatever. But you should label your axes so that way we actually know what's going on. Because these tick marks really can represent anything, and unless you tell us what they represent, we don't know. So the vertex is 0, negative 16. And as I said, it is irregularly shaped. So from there, I'm going to go up 1 over 1. Up 1 over 1, right there. And then from there I can go up 3 over 1, right? So up 3 over 1 is another point. And then from there I could go up 5 over 1. So 1, 2, 3, 4, 5. And there's another point. What would my next move be?
Up 7.
Up 7 over 1, which actually would take me all the way to the x-axis. Hey, I'm going to land right on it. Talk about lattice points. Lattice points, by the way, are what you call points that land exactly on the crosshairs of your coordinate plane. And then, of course, I could find some other points by, whoa, that was like way off. Samsonite. I was way off. So here we go. Mirror, mirror. So, and then I would graph this. Oh, actually, wait. Before I start graphing, question. This says y is less than that parabola. So that tells me two things. Right? This guy right here tells me two things. One, it's dotted.
And it's shaded under.
And it's shaded below or under, right? Because the points less than would be under, right? Because this is y relates to something, so y less than something sounds like a underneath, right? So I'll try to draw my best dotted line parabola. There we are, and shade it. So that means my solutions to this inequality are all of the infinitely many points that are not on the parabola, but all the ones underneath it that are up to but not including it. All right? Not too shabby. Right? So in fact, I could actually even try a check or check a single point if I wanted. So I could say pick a point like here, 0, 0. Do I expect that this point is going to be true for my inequality? No, because it's in the non-shaded region. But is 0, let's see, 0 squared is 0. 0 minus 16 is negative 16. If I plugged in 0 for y as well, is 0 less than negative 16? No, and I wasn't expecting it to be. So that means I shaded in the correct location. So there you go. So that's the idea. Graph the points of the parabola using any technique you know, and then determine whether it's dotted and which way it's shaded. So let's do one more. 29. So let's use the significant points method, the vertex, the roots, the Y-intercept approach for this one. So for the vertex, that is the ugliest V. Let's see. For the vertex, let's find h. H is going to equal the opposite of 3 over 2a. So that's negative 3/2. To find k, that's going to be f of negative 3/2. Meaning I'm plugging negative 3/2 in there. Bam. Square it plus 3 times negative 3/2. And by the way, if you put this in vertex form, you'd get the same vertex as you'd expect. Not bad. Negative 3/2 all squared is, let's see, well, negative all squared is going to be positive. 3 squared is 9. 2 squared is 4. Plus, well, actually 3 times negative 3 is going to be minus 9 over 2. We've got some excited squirrels outside. Or a chipmunk. I don't know. So to combine these, I'd need a common denominator. So I'd multiply this by 2 over 2, this by 4 over 4, if I'm not mistaken. And I would get, what's that, 9/4 minus 18/4 minus 4 times 10 is 40, plus 4 times 8 is 32. So that's what, 72? Negative 72 fourths. So let's see, 9 minus 18 is negative 9. Negative 9 minus 72 is going to be negative 81/4, if I'm not mistaken. So my vertex is the point, negative 3/2, comma, that's an ugly 2, comma, negative 81/4. Which, Skylar, we can actually write this as a decimal if you want. Negative 1.5, and I believe this is negative 20.25.
No,
It is. There we go. I had it on dynamic shading. There we go. So there's our vertex, whichever way you'd like. One of the rare occasions that decimals can be tolerable at times. How do I find the roots? Set the function equal to 0, x squared plus 3x minus 18. So I think there should be more of us writing this down right now, considering I don't think you guys got this all right. Right?
use the
Sure, absolutely. So to figure this out, I could use quadratic formula. I could complete the square. I could factor it. Is it factorable? I believe it is. And I don't have a pattern, and I don't have to AC method it. So let's just find the factors of 18. Let's subtract 3. 1 and 18, 2 and 9, 3 and 6. And 3 and 6, those subtract to 18. What do you know? So x with a 3, x with a 6. Their signs are going to be minus and then plus. And now that I have two things that multiply to be 0, of course I can set each one equal to 0 and solve. How great is that? So x equals 3 and x equals negative 6. Of course, when I added 3 to both sides and subtracted 6 from both sides. Right. And those are not coordinates of the same point. Those are two separate points. That's 3, 0 and negative 6, 0, which it might not be a bad idea to write those points out as well. Let's see. Then I can find the y-intercept. How do I do that?
0 and then
Negative 18.
Yeah, 0 and c, right? So that's just negative 18 or 0, negative 18. So what we have here is parabola. Vertex is 0, negative 18. It looks like it opens up because I could tell that A was positive. And I have to go, looks like it's a little bit more to the, wait a minute. Oh, that's the y-intercept. Yeah, that's, what's the vertex? Sorry, the vertex is this guy. Bam. Silly me. So let me, I need what, negative 1 1/4, and I need to go down at least 20 1/4. And let's see, hopefully this will do. It's a regular shape, fortunately. So let's see what I got. So the vertex is at negative 1 1/2, and then down 20 1/4. So my vertex is somewhere like there-ish, right? My y-intercept was at negative 18. My x-intercepts were at 3 and negative 6. Axis of symmetry, if you wanted it, would have passed through negative 1 1/2, right? Good enough. And then I could mirror the y-intercept point over to this side. Let's see, that's 1 1/2 that way, so half and 1, somewhere like that, right? Oh, that was weird. Oh, glitching. There we go. And it was regularly shaped. A lot of my points would land on really ugly locations if I wanted to do the slopes trick, but you could. But I've got 5 points. Now, question. Is this solid, dotted, shaded? Which way? What?
Solid.
Solid because of the equal to portion of the inequality.
And everything inside of it is shaded.
What do you mean inside?
Like above.
My goodness. Sneezes.
Huh?
Man, I'm getting lag. That's a sad looking parabola. I wouldn't say inside, outside of parabolas. It's better to analyze above or below because you're less likely to make a mistake. So y is greater than or equal to this parabola would be the points above it. So shading above does happen to be on the inner part of the parabola, I agree. So all of my solutions are the infinitely many points inside and including, or above and including that parabola. Right? So that's the idea. That's the idea. So graph the parabola's points however you know how, and then just shading the last part in solid lining, or whatever you want to call it. That's all you got to do. Same difference, right? Not bad. All right, thanks for watching, friends. Bye-bye.